Hello. I am Brennan Loder of the Owlset Lab and I am going to be walking you through how to get started with the rack. This information and more is covered in the configuration and operation guides. Once the rack is powered on and all of the hardware is connected, you're going to run LabVIEW 2019 and open the rack voltage input project. This LabVIEW project allows us to communicate with the hardware. Within the project, you will right-click and connect the compact remote input-output module, or compact RIO for short. Feel free to explore any of the files within the project, but for now, we only need the host side rack control VI and the FPGA side VI open. The FPGA side can be opened from the host side block diagram or from within the project. Once these two files are opened, you are able to change the magnitudes of the voltage and current from the 421 as well as the magnitudes of the voltages from the 735s. You can see this data being received on the FPGA side in real time. As you can see, the magnitude of the data is the same as the magnitude on the slider from the host side. Since this data is being read in real time to a great degree of precision, any slight changes in the magnitudes are picked up. I am going to turn off the 735s and set the magnitudes of the 421 to about 51 kV and 104 amps, respectively. Next, you will want to verify that the data from the LabVIEW project is being transmitted to the hardware. In order to measure these voltages and currents, you will open the accelerator quickset and establish communication. We are communicating through COM4. Make sure all of the parameters match those shown here. Now that we are connected, open up a command terminal. The usernames and passwords are specified in a sticky note which is saved to the rack. After gaining level 2 access, type MET to fetch the phase currents, phase voltages, sequence currents, add sequence voltages. As you can see, the magnitudes that are shown here match the values which were set in the LabVIEW project. This proves that the rack is functioning properly with its hardware communicating in real time. Also, note the phases of the currents and voltages matching what we'd expect from a three-phase system. The last thing that we'll look at in this video is the quickset's human-machine interface. The HMI can provide us with pretty much any information about the machine that we seek, but for now, we're looking at the phasers. First, you see a graphical representation of the phasers from our three-phase system, as well as the phase currents and voltages previously verified. Now that you've gotten started with the rack, your next task is to mathematically verify all of the sequence components shown.